Hello, let's start with the structured questions right now. And we have a first question on a crowbar. Now, a crowbar is actually a gadget which will help you to pull out the nails that's stuck in a plank of wood. You will know that normally if you were to use your hand, it is impossible for you to pull it out. So what you do is we make use of a crowbar and we make use of the concept of moments. In this case, this is your pivot, okay? And you are actually exerting a force downwards. So the most efficient way is to apply it at 90 degrees, and then this will help to pull the nail up. And remember, our formula for moments is force times distance. So in this case, the place where you apply your force is actually much further compared to over here, compared to the distance between the nail and the pivot. So your distance is actually larger. So when you apply your force, you will be able to give a moment that's big enough to pull this up because this distance is small. So this force that is exerted on the nail is going to be quite big. So what effect of a force is used in the scenario here? In this case, this is the turning effect. Remember the effects of forces, you can change the direction, the speed, the shape. It can cause something to turn. So in this case, your answer is it will cause the crowbar to turn. So as long as you have the word turn is acceptable answer. So why does it have a long handle? So crowbar has a long handle because we want to increase this D here. So when you apply a force at a distance that is long or further away from the pivot, then you do not need to apply so much force. So whatever force you apply, when you multiply by a large distance, you will generate a very large turning moment. So because the question says to explain, so let's recall when you are asked to explain something, you must support your answer with a law, a theory, or a formula. So in this case, this is a question of moment. So I support it by writing down how do I find moment? It's a very long sentence here. If you don't have enough time in the exams, you'll just put F times D, but you have to specify what D is. So moments means you multiply the force by the perpendicular distance between the line of action of the force and the pivot. So basically you are writing this, right? So this is your supporting statement. Then you go on to say that when you have a long handle, you increase the distance. So this part here, right? So this is the reason. So because moments is F times D, so a long handle gives you a larger D, and therefore you only need to apply a small force and you are able to then remove the nail or create a large moment. Question 2 talks about a garden chair. What is the what is the force and direction exerted by the garden chair on the ground? Well, in this case, we know that the earth is going to pull it down, right? So the force is weight. You can also put gravitational force. Is also correct, and it's acting downwards. So after a heavy rain, you find that the chair will sink into the ground because after a rain, the ground is softer. So how do you prevent that from happening? So again, it sinks into the ground because of the pressure that is exerting on the ground. So in this case, what you can do if you don't want it to sink, you have to reduce the pressure, right? So to reduce the pressure, there are two things you can do. You can either increase the area or you can reduce the force. So how do you reduce the force? Then just buy a chair that has a smaller weight. So this is what happened. This one, a lighter chair, okay, or a chair with a smaller weight, because a smaller weight means smaller force, so then smaller pressure. Then if you want to increase the cross section, the contact area, then the legs can be changed to a thicker one, right? So you have a larger contact. So when you do this, you have a larger contact area. So basically you want to increase the larger contact area. Please do not just stop here and say larger contact area. You have to continue to say contact area with what? With the soil or the ground, right? So for completion's sake, don't just stop and say larger contact area, always to include contact area with what? Okay, with the soil. Then of course if you don't want to change the chair, then all you need is to just place a board, because then if your chair is resting on a board, then this whole area of the board will be your contact area. So then you will not sink into the ground. The next question is three bricks of the same weight. They are all 30 newtons, but they are placed with different orientation. So which one is going to exert the least pressure? Remember, pressure is force over area. So because the bricks are all 30 newtons, so this is the same, so no change. The force is the same for all the three. So the one with the smallest pressure will be the one with the largest area, because in this case, the pressure and the area, they are inversely proportional. So A will be the answer because A has the largest contact area. So remember, it's not just any area, it has to be contact area. And contact area between what and what? Between the brick and the ground. And then because the question says to the stating portion, state which position, so this is answering the state. Okay, so break up your answers. Then when it says to explain, then I will explain by saying the contact area is the largest, and you must support, right? You must support with a formula. So then I will write down, so it's the reason why the contact area has an impact on pressure is because of this formula. So because of this formula, I know that area is inversely proportional to pressure. So the larger the area, the smaller the pressure. Question 4. Question 4 is a question on some injection needles. And then there are different sizes of injection needle. And it says when you are using the needle, which one can be inserted most easily. So the one that can be inserted most easily will be the one where you can actually exert a large pressure. So same as what we have been saying in the past few questions, the one with the smallest area of contact, so the largest pressure. I think what is lacking here is they should also support by saying that because pressure is the force per unit area, so a smaller area will result in the largest pressure, so it is easiest to pierce through the skin. So I think you have to include this in your answer as well. Okay, it's not in the answer sheet, but I think this is expected. Then the next part is a calculation question. I think this is quite okay. Oh, but I think there should be an error here. Hold on. Okay, I think there is a error here. I've rectified it. So how much pressure is exerted? So the force is 10 newtons, and you divide by 0.0002 square meters, and the pressure that you exert will be 50,000 Pascal, right? So there is an error in the answer sheet at the back. So it should be 50,000. Let's move on to question 5. Question 5 is a question on bubble tea. And those of you who have taken bubble tea, the big straws, you will know that the tip of the straw is very sharp. So why is it that it's much easier for you to pierce through this side than the other side? Well, in this side, the part that is in contact with the plastic cover is this little bit here. So it's actually a small contact area. So you notice for all the questions in pressure, most of the time you are explaining based on the contact area. So it's quite easy to score in your explanation question as long as you support with the formula and as long as you are clear in your explanation. For example, you'll use words like contact area between the straw and the plastic cover instead of just putting the word contact area. So in this case, we start by writing down what we know, that the sharp tip, these little tips here, the sharp tips, it has a smaller contact area with what? With the plastic cover. So since pressure is force divided by force divided by area. Okay, sorry. Since it's force divided by area, or since it's force per unit area, you can write both. Okay, or you can say it is force per unit area. So then in this case, a bigger pressure will be exerted when you are using the sharp tip. Okay, so this is the supporting statement that you must have in your answer. Let's carry on. Question 6. Now, question 6 is a question where you have to draw the force diagram, and there are three forces here. But for this one, hold on. Okay, so so the three forces. Now, for normal contact force, let's remember normal contact force, when you draw, it has to be perpendicular. So this line must be 90 degrees to the surface. So this is the surface. It has to be 90 degrees and it must act away from the surface. So that's why it's pointing away from the surface. So remember, normal contact force away from the surface and perpendicular to the surface. So you draw somewhere near the middle. The weight you must draw from the middle of the box. Please don't draw anywhere else. Okay, please don't draw like far corners or right at the bottom. Please start from the middle or close to the middle of the box. Draw a line that's vertically down. Even though the box is on a slope, the weight is always vertically downwards. In fact, this line here should be parallel to the paper. And friction. Now, the box slides downwards, so I already know the box is going to slide down. So the friction has to be in the opposite direction. So first of all, make sure your arrow is facing upwards, opposite from the sliding down. And number two, make sure when you draw, you have to draw it between the box and the ram. It has to be between the surface. Okay, so this part here is important. If you want, you can also draw it here. If you want, it's also not wrong. You are fine. But you just make sure there's this part here that's between the two surfaces. What is one non-contact force? Friction is contact because the two surfaces must be in contact before you can have friction. Normal contact force, the word contact, normal contact force is already, you can already see it's a contact force. It will only have a contact force when two surfaces touch each other. Okay, so weights, gravitational force. They say from the forces identify a non-contact force. I'm sorry, in this case, magnetic force will not be a correct answer because you need to identify one of the contact force from those that you identify in A. So A does not have magnetic force, so you should not have the word magnetic force there. Okay, and question 7. For question 7, you are pulling a book with a spring. So in this case, the force that you are exerting on the book can actually be seen on the spring balance. A spring balance measures force. So without a spring balance, I can pull the book, but I wouldn't know how much force I'm exerting. So in this case, there is a tension here as well. And you can tell from the reading here how much force you are actually pulling the book with. So compare this spring balance reading when the book is moving with a constant speed on both surfaces. One of the surface is sandpaper, and then the other one is a polished metal surface. So there are two surfaces. So will there be a difference? Yes, if you are pulling it with the same speed, the one on the sandpaper, you need to exert more force because there is going to be friction. Sandpaper is very rough. So you need to say that the spring balance shows a larger reading. Larger reading would mean you are asserting, oops, sorry. So a larger reading means you are asserting a larger force. So when the, yeah, so you are asserting a larger force. Okay, and then the question go on to say, so because of the Why do you need to exert a larger force? Because there's friction, right? Non-contact force, gravitational again, right? The earth is pulling the book. Even if the book is not in contact with the earth, where, when, when you drop a book in the mid-air, the earth will still pull it down because gravitational force does not need the two surfaces to be in contact for it to work. Will the kinetic energy increase, decrease, or remain the same? So in the chapter on work and energy, you learn that kinetic energy can be given by the formula half mv square. So ke is half mv square. So it depends on the mass, it depends on the speed as well. But in this case, if you read carefully, the questions say that um, if you read carefully this part here, right, same speed. That means the book is not moving faster or slower, the book is moving with a same speed. So with the same speed, the same mass, the kinetic energy will remain the same. Question 8 is a question on moments, and they ask how far should a 10 Newton weight be placed. So over here uh, you only have a 8 Newton weight, so this is coming downwards, right? So this is clockwise, and if you want to balance it, then the clockwise moment and the anti-clockwise moment should be the same, right? And because they are the same, you have so 8 times 0.5 equals to, you want to place a 10 Newton weight, right? So you don't know where to place it. So then the distance is the unknown. Okay, so 10 sorry, not 10 not 10 kilogram, it makes a difference, it's 10 newtons. So then the answer should be 0.4. Okay, so 0.4 times 10 newtons is equals to 0.5 times 8 newtons. And when the moments clock and anti-clockwise are balanced, the bar will be balanced. Okay, last second question. A man is pushing a box on the ground, and when you are pushing the box, what are the forces acting on it? The contact force is acting on it, right? So because the box is touching the ground, so definitely it's in contact, so it's contact. You could call it normal contact force actually. Okay, I think you should be calling it normal contact force. There should be a friction because you are pushing it to the right, so the friction should be acting to the left. Same as the previous question on drawing of forces. Make sure you draw your friction between the, the box and the ground. And your weight, you should start drawing from the middle of the box. Okay, I think this is not really in the middle. You should draw it more towards, I can't move this, but you should draw it from the middle of the object. Okay, make it more obvious it's from the middle. So how much work did the worker do in 1 minute? Well, the worker pushed with 80 newtons, the box moved with 40, the box moved 40 meters. So this is the force, this is the distance. Do not be distracted. Do not be distracted by the mass of the box. This is not required in the working for work done. To find work done is the force multiplied by the distance. So you get 3,200. And there are, okay, so that part is drawn. This is the man walking on a frozen lake to reach the other side. And this is the area of the sole of his snowshoes. So what is the pressure that's exerted by the man on the ice? The man's um, weight is 852, so force times divide by area. Now this man is actually standing in the position shown like this. So if you look here, can you see? He's actually standing with 2 feet on the ice. So therefore, this is only the cross-section area for one shoe. Sorry, this is only the cross-section area for one shoe. So therefore, you need to multiply by 2 because both shoes are touching the ground. So you get answer 14200 Pascal. And when you start to see that the ice is thin and might just give way because your 14,200 pascal may be too large for the ice to hold, then what should you do? Well, then you have to, because at that point of time, it is not possible for you to change your weight unless you are carrying something very heavy, you quickly put them aside. But basically, if you are standing by yourself, this force is actually your weight and nothing much you can do about it. So if you want to reduce the pressure, then you increase the area that's in contact with the ice. So the best way to do it is when you lie down, then you have more area. So lying down increases the contact area. Again, you must mention between what and what, right? Between this person and the ice. So with a larger contact area, the pressure will be smaller. So why is it smaller? Because area and pressure is related by this formula. Okay, so I think we've come to the end of the worksheet. If you have any question, please go back to your teacher and we'll be very happy to help you. Okay, so thank you.